Okay, today's lecture, 3D computer graphics. Okay, 3D computer graphics, geometric modeling. That's the topic for today. We are on exactly 10th week. Okay, so today's lab exercise topic also 3D graphics, 3D geometric modeling, and behind the technologies theories lecture for today, of course, 3D computer graphics. So far, we have reviewed 2D computer graphics, general CAD systems, general computing issues, general design computing issues. So far, okay, for last 9 weeks. But actually, we have more weeks. But next step to next week, we have midterm exam scheduled. Theory, okay, theory, no lab exercise, theory. Next week, I'm going to show you example questions for the midterm exam. Anyway, series of 3D geometric modeling and visualizations for using SketchUp. But it's not the final. Your final project, next week, you are going to pick what is your final project. Okay, I'm going to assign you one by one for the final project, designer's work. So you have to choose one of them, and you have to rebuild your design model using SketchUp. You have to draw some draftings, 3D renderings, 3D representations, 2D diagramming, whatever it is. For developing design, you have to build your own computational model, okay? After that, that's the beginning of your presentation. You have to prepare your design presentation using PowerPoint and Photoshop retouch, whatever it is. You have to prepare PowerPoint slide or Prezi slide for your final presentation. 5-minute oral speech, okay? Even if it's not your design, that's fine. You can reinterpret your design, designer's design, based upon your computational modeling and visualizations. That's the final project. Anyway, rest of lab exercise going to be handling your final project as well. Here I list up what to do today, okay? Something about 3D geometric modeling using an application called SketchUp, okay? For doing that, we need to review 3D geometric modeling. What is 3D geometric modeling? What is the difference between 2D drafting, 2D drawing, okay? In other words, geometric modeling in 3 dimensions. What this mean by in 3 dimensions, okay? So what is this? Actually, this is a product. Precisely say this is a chair, okay? This is a chair design. But even if this is not that curved design or freeform design, this is totally, take a look, this is front view, okay? This is top view. Okay, now you see, okay, based upon the top view, probably this is the sitting back, okay? And this is kind of leg. But now you recognize the structure for the leg is looking something different. But according to the front view, anyway, this is probably sitting area, and this is the leg, and probably you can hold your arms on those two parts, okay? But it has something different location. Okay, based on this left view, now you can figure out the shape of this geometry, okay? Even by right view, you can now figure out the shape of this chair, this object. All line-based drawing, no curves. Entire angle, totally orthogonal. Orthogonal means 90 degree, okay? Perpendicular. Even bottom view, take a look. According to the series of given floor plan, now you can recognize the 3D shape. But this is perpendicular, orthogonal, line-based, line stroke-based, very typical design. Actually, this is not a typical design chair. This is kind of looking very different, looking weird chair. But anyway, no curve lines, no freeform shape, no non-uniform shape. It's totally uniform shape. But actually, when you see this kind of 3D, what is this? This is standardized 3D view, so-called isometric, okay? Isometric 3D view, but different style. The style for this one is wireframe. This is wireframe, okay? That is why you can see entire lines, even if it's invisible. Take a look. At this time, hidden line removal, okay? And also, this is not isometric. Those are perspective, okay? Perspective drawing with hidden line removal, rendering. The rendering type, visualization style for this one is line stroke, okay? Wireframe. Visualization style, rendering style for this one, they all line stroke, line drawing, but perspective, okay? Not isometric or axonometric. Anyway, thanks to this kind of 3D rendering, 3D visualization, you can easily recognize the shape of this product, okay? Shape of this geometry. Conventionally, we have used this series of documentation in this view, okay? What is floor plan? If the product is building or building interior, what is floor plan? Which one is floor plan? Of course, top view, okay? Top view is floor plan. But the height of the, actually precisely say, it's not a top view actually. Okay, section cut, height is around 1.2 or 1.5 meters, okay? From bottom, height is around 1.2, 1.5 meters. The section profile of the elevation is going to be the floor plan, okay? That is the floor plan, conventional floor plan, definition of the floor plan, okay? De facto standard in industry standard. Anyway, top view is floor plan for interior, for architecture, okay? And those are elevations, okay? So we don't use this kind of drawing, bottom. But instead, we need reflected ceiling plan. Reflected ceiling plan for ceiling design, lighting design. Some detailed structure for the ceiling structure, okay? Reflected ceiling plan is one of the standard, okay? Elevations, floor plan, and reflected ceiling plan. That's standard drawings, drafting for architectural design. Anyway, convention is here, okay? Plan views. But we are working with 3D computer graphics. So what if you generate this 3D model? Not this is 3D drawing, okay? If you draw in 3D, that's it. It's finalized drawing. But if you have 3D model, you can extract front view, top view, left view, right view, even section cut, okay? Section profile, section view. That's exactly what you can get, what you can extract from your 3D model, okay? From 2D drafting to 3D modeling, that's the change we experienced in last some decades in CAD history, okay? I told you top view is floor plan, front view, another plan view, but usually we say this is elevation, okay? So 3D axonometric, isometric, but still in 2D drawing. How about perspective? You experienced a lot of perspective drawing in your drafting course. Hand drawing, freehand sketch, again and again, okay? Whatever you capture the scene, it's just still 2D image, okay? Not a capturing or extracted image from 3D. But what if you have 3D surface model or even 3D solid model? If you have a 3D model, you can place your camera with appropriate views, and then you can get front view, top view, right view, left view, even section view. Okay, you can place a section plan, and then you can get specific section views. Okay, whatever it is, anyway, you can get this kind of visualization. What I mean is you can extract those standardized views from 3D model. Okay. But even if you have 2D drawings, this kind of 3D cannot be generated in automation. You have to build 3D model first in surface or solid. What is surface and what is solid? Usually we used 2D drafting, but now we are using 3D model. Okay, so let's take a look something detailed about 3D models. You know the meaning of this symbol. Okay. This is perfect subset of this one, okay? And this one, subset of this one, subset of this one, and entire those elements are the subset of this one, okay? Which means this is the biggest one. So what are these? This class we are dealing with this area. The first one in CAD history, okay? 2D drawing and drafting. Second one is surface-based 3D. Okay. The third one, advanced one, is solid model. Next one is parametric. The last one, in other words, the most advanced one is product data modeling, or simply say BIM. Okay, building information modeling. In a nutshell, elementary school level CAD, okay, in terms of CAD history, middle school level, high school level, university level, postgraduate level, okay, the most advanced one. So unfortunately, this class is dealing with elementary and middle school level in terms of CAD history, in the perspective of CAD history, okay. In other words, we invented computer-aided design, CAD, okay, computer-aided design system around 50 years ago, 40 years ago, 30 years ago, 20 years ago, 10 years ago, okay, roughly say. So what is the most cutting-edge technology? This one, okay, but we need to tackle step by step, okay, we need to take one by one. Next year, third year in digital design and BIM course, in my course, you're going to handle parametric modeling, some program-based modeling, including solid model, in the BIM class, okay, using totally different type of applications. But anyway, now we are dealing with surface-based 3D as well as 2D drafting. Let's take a look in the perspective of computer applications, software. First and second one, in other words, elementary and middle school level CAD systems are here, okay? The dot line here simply divides this semester subject and the rest of topics we have, okay? Take a look. SketchUp, of course, in this area. AutoCAD, of course, in this area. This is not 2D software, okay? You misunderstood this is 2D drafting, professional drafting tool, but AutoCAD, of course, it is 3D application, okay? Next week, we're going to deal with a little bit about AutoCAD. Anyway, this is another 3D application, but still in surface-based 3D. How about 3D Max? Of course, this is in surface-based 3D. How about Rhino Grasshopper? It's also in this area, okay? Surface-based 3D model. How about other area, BIM area? Autodesk Revit is a representative one. But anyway, our subject especially focusing on SketchUp. So what is surface model? What is surface-based 3D? Take a look. This is a surface. What is the main characteristics of this kind of surface? How about thickness? Does it have thickness? No? Okay, in terms of mathematics, in terms of computer science, good question, good answer. No thickness, okay, zero thickness. Because that's the characteristics of surface, okay? Surface doesn't have any thickness, zero thickness. So this one, in other words, couldn't be existing in real world, okay? Even if your paper or film is looking like this surface, it has thickness, okay? 1 millimeter or sometimes 0.001 millimeter. Anyway, it has thickness. How about your hair? Your hair really thin, smooth, but it doesn't mean that it has zero thickness, zero radius. It has 0.001 millimeter radius, okay? So this kind of surface is mathematical definition and virtual object, not real world object. That's the point, okay? In real world, there is no such object. Take a look. The shape is looking okay, but take a look, the surface, zero thickness. It's not possible. We cannot make this kind of object in real world. They are all conceptual, mathematical definitions, okay? But anyway, surface modeling is very, very good to visualize any type of 3D objects. Not only in the real world object, but also in virtual space, such as game. So this is lightweight, okay, compared to solid model or something advanced. Very easy and primitive way to represent 3D. That is why game engines or some computer general 3D systems, most of them adapted surface-based 3D in general. But however, the problem is we are dealing with real-world objects. They are all solid 3D. You are not game designers. You are not supposed to be visual art designers or cyberspace designers. We are all in charge of handling some physical objects, physical design elements, okay? In real world, in architectural domain, in our area. So the problem is semantic integrity. We have learned what is semantic integrity, okay? Our computational model, what if our computational model always surface-based 3D, but we are dealing with solid objects anytime? Some problems, okay? Our computational model couldn't be same to real-world object semantically, okay? So that is why something advanced one from surface model developed, something like solid model, okay? So what's solid model? Here is a simple definition of solid. A solid model is an unambiguous computer representation of a physical solid object. What is the difference between solid and surface-based object? What is unambiguous? Defined by Rakucha. Take a look, non-solid 3D models. Non-solid 3D model means, okay, take a look. Three planes and single plane here. Single plane here is zero thickness, okay? In real world, there is no such object, okay? How about this one? The two box cubic shapes are looking okay, but how about this one? Dangled object, dangled surface. Because of this surface, this object is not a solid model. How about this one? Okay, this part is looking okay, but take a look, radius. Radius is shrinking, okay? Specific number, radius, but at the end, zero radius. That is why this part only displays a line. I told you, in real world, a line is another conceptual object, not real object. There is no line, no surface in real world, okay? Line looking object, something like hair, but hair has thickness. But this one has zero thickness. So because of this line, this is not a real world object. How about Klein's bottle? You may not know what is Klein's bottle, but hopefully you know what is Möbius string, okay? This kind of Möbius string doesn't have front side and back side, okay? Front side and back side, it's connected. So you cannot judge which side is front side, okay? Simply because front side and back side, they interlinked like this, okay? 3D version of this Möbius string is here, Klein's bottle, okay? Take a look. Which is inside and where is outside of this object? Okay, if this is outside, take a look. This is going to be changed the inside of the surface if you follow by the surface line, okay? So this one doesn't have inside or outside, okay? It's kind of upside down, complicate. This is the problem of surface model. So overcoming those unambiguous, actually not unambiguous, they are all ambiguous and something ill-defined, okay? To overcome those mathematical problems, that's why we need solid model. Okay, some more examples. The first one, this is devil's fork, famous devil's fork. You know this is a fake, okay? This is a trick, just an illusion. This is invalid, of course. How about this one? As I showed you this one before, this one is looking like this object, but actually this one can be this one or even this one, okay? That's the problem of this kind of hidden line wireframe 3D, okay? This is the problem of unambiguous definition. Even if we have some specific definition, it's not easy to determine this one is computationally or mathematically well defined. So we need to distinguish ill-defined structure and well-defined structure. Well-defined structure, which means possibly real-world object, okay, not cyberspace object. Okay, to figure out geometry and topology, that is another topic for today. We have to know what is geometry and topology. In Korean, geometry is 기하학, okay? What is topology? 위상기하학, okay? So you have to differentiate what are they. So why we need such things? Now we're going to deal with 3D computer graphics using 3D computer software, 3D definition. What if you don't know the fundamental theory about subgeometric components of your design element object, such as line, polygon, shell, vertex, and their relationship, and so on. Okay, let's take a look easily and quickly using a simple example. What information is necessary to represent this shape? Okay, now we are using CAD tools, computer graphics tools. This is not a hand drawing, of course. This is computer representation, a rectangle shape, yellow colored rectangle shape. How to define this one? Firstly, okay, this is 2D, okay? So at first, we need Cartesian coordinate system, XY coordinate system. we need 4 points at first, at the beginning of the definition. 2.1, 3.2, 2.3, 1.2. Series of 4 points we have, okay? How about their connections? So-called 4 lines. 4 lines for one surface with yellow color, okay? That's the mathematical definition of this rectangle shape, okay? Series of definitions for the rectangle shape. Now the computer can recognize this one based upon this XY coordinate system. This is geometry, okay? How about topology? Let's take a look. In this case, we are not calling point or lines at this time. In terms of topology, we are saying vertices and edges, okay? Take a look. V0, V1, V2, V3, they all connected by edges, okay? So here is the relationship. Edge 0 is the connection between vertex 3 and vertex 0. In the same way, we can define 4 edges, and at the end, one face is composed of 4 series of edges, okay? This is topological definition. Okay, let's take a look. Geometry versus topology, okay? Different geometric shapes with the same topology. Take a look. V0 through V1, V2, V3, and another V0, okay? And take a look this one. V0, V1, V2, V3, V0. Same topological relationship, but different because of their different geometric location, output shape looking totally different, okay? Same topology, but different geometry, okay? That's the issue. Next one, same geometrical location, but at this time, different topological relationship. Topological relationship, but at this time, different relation, which defines totally different shape, okay? Same geometry, but different topology. So, at the end, to represent this shape by computers, what we need in terms of mathematical definition in lower level, we need both, okay? Both geometry and topology mandatorily required, okay? Geometry defines values, locations of points. Topology defines relations between points. So why you need this thing? Okay, today in lab exercise, you're gonna draw some series of lines for section drawing, and you're gonna make 3D, extrude, revolving, lathing, sweeping, using follow me or push-pull function in SketchUp. Even if you don't know what it is, even if you memorize, okay, making 3D using follow me, making 3D using push-pull, fundamental behind the mechanism is here, okay? This is the behind the technology, simply say, okay? Lower level mechanism and technology behind your user interface of SketchUp is exactly this one. So we need to take care of something like this, fundamental issues. Let's take a look some comparison between geometry and topology. Under geometry, we have points. Their connections, lines. At least 3 lines going to create one single surface. At that time, that is triangle surface, okay? Group of surfaces going to be one single space, okay? One volume. Take a look. 4 points, 4 lines, one single surface, okay? This is geometry. How about this one, topology? vertices and their connections for edges, okay, and one single face. That is the definition of point line surface and vertex edge face. How about 3D? So far, this one is 2D, okay? How to create 3D for making space or shell? Very simple, okay? Take a look. Z direction. This is extrude, okay? Extrusion to create a 3D object. Also, this one created for 3D object, but it's not enclosed. That is why this one is looking totally different. How about this one? The angled surface object. Those two are something ill-defined, so-called surface-based model. In SketchUp, in Rhino, in 3D Max, you can define those unclosed 3D object as well without any problem because they are surface-based 3D model. But why we need to make this kind of enclosed structure? Closed loop. Take a look. This is closed loop and those are not closed loop, okay? Closed loop will create 3D object without any problem like this, okay? So this is the way of creating 3D objects. Those two are surface-based 3D model. In real world, there are no such object, okay? No such things. Zero thickness, but 3D, it's not possible, okay? So in this area, this is so-called 3D solid model. In real world, I told you, we're not gonna deal with game or some virtual things. We are dealing with a physical object, which has volume, thickness, weight, something physical object. So these are real world objects, solid or even surface model. But this one only can be handled by non-solid 3D model, so-called surface-based 3D model. Simply say SketchUp, 3D Max, Rhino, okay? It is, but anyway, this is really good for visualization. Anyway, this one can represent anything, any 3D structure, okay? Because it's really lightweight and handy, good, powerful for visualizations. Okay, let's take a look some 3D geometric modeling issues in CAD system, CAD tools. Let's take a look this one, geometry for making 3D objects. Take a look. For building a box shape in 3D, how many sub-components, sub-geometric components we have? Take a look. In terms of topology, we have vertices, their connections, edges, and their groups, at least 3 edges going to create one single face. Face is going to be polygons and surfaces. At the end, at last, one single 3D cubic shape. So modeling 3D object, simply say, controlling 2D or 3D subcomponents in terms of geometry or topology, okay? So what if you modify the shape of this one? You have to control location of vertices, location of edges, location of polygons using push-pull, okay? Today, in the lab exercise, by using SketchUp, we're going to deal with this one, how to manipulate the shape of this 3D object, controlling sub-component, sub-geometric components, okay? Modify sub-geometric components. That's the topic. That's the issue while you are creating 3D. Okay, let's briefly look at how many ways of creating 3D. The first one, actually not first one, I put number 0 because this is not creating 3D. This is something about making primitive objects. What are primitives? Take a look. Cone, cylinder, wedge, sphere, torus, box, pyramid, all they are something predefined 3D object, okay? In terms of 3D, they are all predefined, and if you click box icon or sphere icon, you can easily get those 3D objects in 3D application. But actually this kind of triangular plane or rectangular plane, they are not 3D, but anyway, in primitive definition. So you can easily get this kind of cylinder while you are simply clicking cylinder button, okay, in 3D Max interface. In SketchUp, actually there is no primitive object. You have to draw and make something. Anyway, that's why I put the number 0, okay? This is the first way of creating 3D. Representatively and officially, extrusion is the fundamental way of creating 3D. Take a look, X, Y in 2D section and Z direction. That's extrusion, okay? This is SketchUp interface, 3D Max interface. Draw something and extrude with specific height, specific thickness numbers. How about in SketchUp? You know what is this tool, okay? Push-pull. By using push-pull, you can make some 3D using specific numbers. You can type millimeters, centimeters, meters, whatever. This is the easiest and the fundamental way of creating 3D. How about next one? Lathing. Lathing means revolving, okay? There is an axis and the section profile. This one can be revolved in order to create totally different shape. This is another way of creating 3D. Take a look. This is SketchUp interface. By using y-axis, you can make this kind of shape, okay? In today's lab exercise, I'm going to show you how this is going to be created. Also, 3D Max interface, you can find out. The most important thing, the most commonly used one is sweep, okay? Sweep. Sweeping a section profile onto a polygon path. Take a look, 3D Max interface. And take a look, SketchUp interface. Okay, two components you need. First one is section profile. Second one is the path, okay? So if you put this one is a section and the path is here, and then you can get this kind of 3D object. This is a representative way of creating 3D. Number 3, sweep. How many ways for creating 3D? Do you think there are more ways? Actually not, okay? Very few ways in terms of computational definition, such as skinning, Boolean operation, constructive solid geometry. We're gonna take a look a little bit more detail later. But anyway, today my point here is only number 4, okay? Number 0, 1, 2, 3, 4. That's it. No other ways. Precisely say, number 1, 2, 3, extrusion, revolving, sweeping is almost the same. One 2D section profile and the path, okay? Extrusion has one single path, okay, Z direction. Revolving has circular path. Sweeping has something different path definition, okay? That's the difference, but eventually same. That's my point, okay? Okay. After 10-minute break, we're gonna quickly finish. Okay. Back to the lecture material. Let's quickly walk through the rest of the slides. 3D CAD and graphics software interface. The course title, of course, CAD and graphics, okay, this semester. But nowadays we are dealing with 3D, focusing on geometric modeling. So we need to take a look some interface issues regarding CAD and graphics software in 3D. So here I simply visualize representative software we are using. We are learning SketchUp, kind of old version logo, and this is newer version SketchUp logo, and the famous Rhino and Grasshopper. NURBS modeling for Windows. NURBS means non-uniform rational B-spline, which means very, very smooth, complicated curve lines, okay? Very well-defined curve lines can be represented, defined, and visualized by Rhino. That's the power of the Rhino. And 3D Max. We have Autodesk material, Autodesk Mental Ray Renderer. Of course, V-Ray is still available in 3D Max. That's why we are using 3D Max. And also architecture and design materials, presets we can use. That's why we are using 3D Max. How about the most up-to-date versions in Autodesk applications? AutoCAD 2017, I told you today, AutoCAD not just a 2D drafting tool. It's one of the 3D surface-based modeling tools, okay? It's 3D tools. But anyway, very good to precision drawings. Anyway, AutoCAD 2017 is the latest version, 3D Max 2017, and the Revit. Revit actually is the subject for next year, okay? Next first semester or third year in digital design and BIM course. One of the most advanced features in design computing. But anyway, you need to take a look at the software we have. As we reviewed before, this is 3D Max interface. Take a look. Even SketchUp, you are feeling something complicated. But this kind of 3D Max, it's kind of overwhelming, okay? Very complex. It's not easy to figure out what to do. Even you want to create a box shape, you don't know what to do. That's the problem of GUI. We already reviewed command line interface, graphical user interface, GUI, and NUI, natural user interface. General software we use today, GUI and NUI base. But unfortunately, we have to use part of command line interface, mostly based upon messy and complicated, sophisticated GUI interface. So general computer graphics software for efficiency and precision, okay? How about 250 millimeter thickness? You have to type 250 rather than saying 250, okay, in English or even in Korean. It's not precise. Sometimes typing 250 is faster and easier. So AutoCAD command line, we have to type amount of commands and numbers. Even in SketchUp, you have to type multiply 10 for copying 10 arrays. Okay, ideal interface for 3D modeling, laser scan image processing. I show you drone-based 3D image capturing, 3D laser scanning, photogrammetry, something beyond the keyboard and mouse using hologram, virtual reality, augmented reality. That's an ideal interface. But in real world, most 3D graphics tool handling 3D objects on 2D screen. Even this is 2D screen, okay? Whatever something visualized on top of this screen, that is 2D projection. But we are dealing with handling 3D object. That's complicated, okay? That's not that easy. So another one is too many icons, too many sub-menus, too many buttons, too many ribbon interface, Windows interface. That's the limitation of GUI, okay? Graphical user interface. Anyway, nowadays we have something advanced interface system, but anyway, at the end, complicate. It's not easy. The gap between the ideal interface and real world interface and in real world experience, the gap makes you hard to get 3D graphics. But actual reasons are here. Why 3D graphics software is too hard to learn? Why you feel Rhino is looking complicated? Why you feel even SketchUp is difficult to learn? Okay, do you know these? Ray tracing, bump mapping, UVW, polygon, sweeping, camera and lens, and so on. Okay, do you remember we have learned something about sweeping today? Also, we have learned something about camera and lens last time, okay? And you know what is focal distance. You know field of view. Hopefully you know what is knobs. Even I told you briefly, non-uniform rational B-spline, one type of freeform, free surface curve, okay? And global illumination, ray tracing, something about rendering. While we are learning, dealing with V-ray, the terms are introducing and something we need to take a look anyway. So without understanding what are these, learning 3D Max, learning Rhino, learning Revit, learning Blender, simply say learning SketchUp is equivalent to memorizing the order of clicking buttons among hundreds of icons in a complicated GUI interface, okay? So my point here is understanding, figuring out behind the technologies, not front-side user interface issues, okay? If you understand the logic behind the technologies, mechanisms, rather than the order of clicking buttons, you can learn any complicated modern 3D modeling rendering tools like Rhino, Maya, Blender, Digital Project, whatever it is, you can learn without any problems, okay? That's my point. Fishing rather than fishes, okay? If you figure out the behind the mechanism and the technology you are using for dealing with 3D or dealing with 2D, bitmap, raster, vector, whatever it is, rest of the issue is simply get used to the user interface, SketchUp interface, 3D Max interface, Revit interface, Rhino interface. That's it, okay? If you get used to it in 1 or 2 hours, thanks to the documents on Google, YouTube, video, tutorial, and then you can get an expertise in that application. That's my point. Let's quickly look at SketchUp basics. In today's lab exercise, we're going to deal with SketchUp in detail. But anyway, used to be Google, but nowadays Trimble, one of the Trimble application. Trimble bought SketchUp from Google, okay? Trimble is one of the big software company, especially focusing on urban city level, GPS, positioning system, satellite system, and so on, okay? Something bigger than building scale. So anyway, in our domain. Take a look this 3D object. If the inside is hollow, that is surface space model. This is SketchUp model, okay? The mechanism of SketchUp model. But solid model has always solid field like this. Or, okay, this is not just a visualization issue. In its definition, computational definition, this is solid, okay? Such as Revit. But 3D Max, Rhino, SketchUp, entire mostly used 3D applications nowadays for visualization purpose. They are all surface-based 3D like this. In SketchUp, we need to control edges or faces. And collection of edges and face, they going to be something like this, complicated object. This building, including some interior finishes, interior components, roof, structural things, entire things could be defined by face and edges, okay? Very complicated and many many faces and many edges for your design final product. Take a look. Collection of straight lines at the end going to create curve line. How about 3D surface? Take a look. This one is looking some good visualization in smooth edge, but edges are smooth, but still there are some straight lines, okay? One single polygon is always flat. Take a look. This one is looking very smooth, but mesh structure of triangular shape, of course they are all in this flat surfaces, flat surface base, okay? That's the way of creating 3D in surface-based 3D system. SketchUp tips for interior architects. I put an emphasis on this one, scale and dimension, okay? First thing is scale and dimension. Second thing, scale and dimension. Third one, again, scale and dimension. For architecture, for being an architect, for an interior architecture design, you have to know, you have to take care the concept of scale and dimension. Okay, even if I say again and again scale and dimension, you usually skip this very critical aspect of design. For example, you usually create windows frame border in 50 centimeter, 500 millimeters. You usually create 1 meter thickness walls, 2 meter thickness or 2 meter radius of columns. Or sometimes you create just a 10 centimeter radius of columns. There are no such things, okay, in terms of human scale, okay? That's my point. You have to carefully watch your built environment. There are no such objects. But there are some standard, okay? What is the standard width of door? Usually 900, 800, or a very small, narrow door has sort of 600, 700 millimeters in its width, okay? But sometimes you create too narrow door or too broad doors, okay, out of standard. That's my point. We have to take care of scale and dimension, okay? That's why I put some note, okay? Type 10 means 1M. Type 4M means 4 meters. /3 means divide 3. Star 10 means multiply 10. We actually experienced those things before. Today also we're going to deal with this part. Double click, push pull, distance, snapping, and tape measurement tool or dimension tool, as well as some more, okay? Precise control for vertex edge face, components, different views, animation views, scenes, layers, different viewing options, shadow casting, and a lot more. A lot of techniques, how to learn the techniques for SketchUp. I told you, fishing rather than fishes, okay? We have amount of very well-made documents, references, tutorials. I encourage you to teach yourself based upon my requirements for today's lab exercise and final project and so on, okay? Okay, so far we have reviewed some basics about SketchUp modeling. How about visualization in SketchUp? Also, we experienced something without any experience in some few weeks ago using SketchUp and V-Ray render, okay? A preview of SketchUp 3D rendering by V-Ray. Take a look, this kind of V-Ray tutorial, YouTube tutorial. Lots of examples you can learn. And example render scenes. photorealistic render scenes and some another type of photorealistic render scenes given by V-Ray website for SketchUp. V-Ray is a plugin, so you can download the demo version or you can buy it for Rhino, for SketchUp, or for 3D Max, okay? Getting this kind of rendering tools. In vray.com, you can get the V-Ray renderer, this one, okay? We're gonna use this one for demo version in our class for the developing some lab exercise hours, okay? Demo versions. The last thing you need to know is 3D warehouse. Thanks to SketchUp, SketchUp is easy to use tool. There are many people in the world, in this planet, okay? Many people use SketchUp for free. So they already modeled something, existing buildings, existing sculptures, artworks, furniture, automobile, even Iron Man, okay? They already modeled and uploaded. That's the website, 3D Warehouse. So one of the today's lab exercise is using 3D warehouse models for your decorating your room, your design room, okay? This is the snapshot of 3D warehouse. You can search anything. For example, if you want to download IKEA table, search IKEA, or Herman Miller office chair, type Herman Miller. Or if you type some classic interior design, and then you can get entire classic interior components in order to reuse on your design, okay? So 3D warehouse, using 3D warehouse is another topic for today. Let's move to the lab exercise, okay?